f, whoa. This one here is f, this is g, f prime. Okay, your test will be on Wednesday next week, so make sure you are prepared. It will be on derivatives. So, what we do is, it's a numerical base to a variable exponent. So what are we going to do? We're going to make sure our phones aren't out, because that's not helpful. And then we are going to rewrite it, because it's numerical base. Rewrite it. Ln the base. And then derivative of 5x cubed, which is 15x squared. G prime, it's this to the half. So I'm going to get 1/2 g to the negative 1/2, and then derivative of the inside is 3. So I technically get 3/2, 3x plus 1 to the negative 1/2. Now, when you have a numerical base, you do chain rule, you end up writing it twice. So I'm going to be able to take that numerical base out of both terms, right? When I do product rule. The second one, it's a chain rule again, g prime, so I'm going to be able to take one of those out of each term. So whenever your f prime or your g prime are chain rules, you'll be able to take GCS out of them. So, y prime is g times f prime okay, plus f times g prime. All right, term 1, this is where I lose people. Term 1, term 2. I don't want to lose you. So we have a base 4 to the exponent of 5x cubed in both terms, correct? So I'll be able to take one of those out. Okay. Then I have a 3x plus 1 to the half and a 3x plus 1 to the negative 1/2. Which one do I have to take out? The negative 1/2. Then the negative 1/2 will be completely gone, and the 1 to the half will turn to a 1 every time. Okay, then I also have, some people take out 3/2, some people take out half and then take a 3 after. That's fine. I'll do it into 2 steps if you want. So this one is over 2, which we can't have an embedded fraction, so I'm going to take a half out as well. So what is left over? Okay, so 3x plus 1 to the half, take out a negative 1/2, is just 3x plus 1 to the 1. Or you can just write it like that. 4 to the 5x cubed is out. Ln 4 is still there. And when I take a half out of 15, what does it turn to? What's 15 divided by half? No. What's 15 divided by half? When you divide by half, what do you actually do? You get 30. You multiply by 2. So we're going to get 30x squared. Shh. It's because this one is over 2, and they will never have an answer with a fraction embedded. Yes. Because if this one is over 2, and they will never have one with a fraction embedded. You're not going to ever be allowed to have in this square bracket a fraction. Because they're never going to give that answer. So you can leave it that way, you'll never match multiple choice. Because they're not going to have a fraction in the numerator over a fraction. They're going to pull that out and drop the number to the denominator. Every time. So I have to take this 2 out. I can take it out as a half instead as the 3. So I take the 4 to 5x cubed out. I take the 3x plus 1 to the negative 1/2 out. And when I take a half out of 3/2, it's actually 3/2 times 2, so I'm just left with a 3. Now this is one term technically, and so is this. Is there anything else I could have taken out? No. A 3. What? So this is 3x plus 1, ln 4, and 30x squared, which are all multiplied. I can take a 3 out of the 30 and a 3 out of the second term. Can you guys stop talking, please? So I can take a 3 out. So in a second step, if I want, I can go 4 to the 5x cubed, 3x plus 1 to the half. Where's that going to go? It's a negative 1/2. It's going to go to the denominator. make it positive. The 1/2, the 2 is going to drop down here. And then I can take a 3 out of this black term and this one here, so I can take a 3 out. And then I'm left with 3x plus 1 ln 4 times 10x cubed. Bless you. 10x squared, I mean, plus 1. Done. You will have to take that fraction out. If in term 1 and term 2 of product rule, you have it over a 2, or you have it over a 3, or you have one of the terms over a 4, you have to take out a quarter, or a third, or a half. It comes out of the one term, and the other one gets multiplied by that number, every time.
All right, let's go over this.
All right, yeah.
So nothing in the square bracket should ever be a
Yeah, exactly. So if one was like a half, you're going to pull out a half, or even if it's like 7 halves, you can still just take out that one. And that will just say a 7, and the other one will be multiplied by 2.
Oh, it's not even 5, so now.
Okay.
So what do you put?
Number 2. Number 2 is a quotient rule. So, all right. F, G. What's the derivative of sine? Cos. 3x squared times what? 6x. Okay, what about G prime? E to the 5x is a numerical base to a variable exponent, right? We rewrite it. Ln the base. What's ln of E? 1. What's derivative of 5x? 5. Okay. So G prime of x is goofed. So we get G F prime, which is 6x cos 3x squared. If you write it the other way, it doesn't really matter. Okay, and then minus. You have to watch yourself. You'll put a plus sign in there, and if you don't, good on you, because I put a plus sign like every 4th one. It's out of control at this point. So put a minus sign in. See, I started to put a plus. You see on the wrong, but I recovered with a really thick minus sign. Okay, G F prime, and then F G prime. Now, some people will say, well, G prime is a chain rule, so I should be able to take something out. True. You'll be able to pull e to the 5x out. But is F prime a chain rule? Or is it just a derivative? It's just a derivative. Tans and cotans and all those are chain rules when they have a squared or a cubed or a 4 in the middle, right? Because then you put that number outside and you chain and chain and chain. But when it's just a whole sine 3x, that's just cos 3x. There's actually nothing in common. There won't be anything you can take out of them. It's the greatest thing ever because they're not a chain rule. Remember, chain rules are when you can GCF things out. Okay. So, and then don't forget your denominator, which is like an epic failure that I use. Okay. So we get G prime of x. You take an e to the 5x out. And then you have a 6 and a 5. Can't get out. X doesn't exist. Cos and a sine. So we're done. So we have 6x cos 3x squared minus 5 sine 3x squared all over e to the 5x squared. And what can I do? That one and that, right? 1 for 1. And so your actual answer is 6x cos 3x squared minus 5 sine 3x squared all over e to the 5x. So, implicit differentiation itself is not hard. It's just different. At least the derivatives that are involved with it are not difficult. They're often like a power rule or something like that. Now, implicit differentiation comes into effect when you don't have a function in y equals format. When the y is embedded somewhere in the equation. Okay? So if we look at this one, we have an x squared plus y squared equals 25. Is my equation in y equals? No. All right. Paying attention, every single person, because I don't want to be re-asked why this happens. Okay? So, every time you have taken a derivative of an x, you don't realize, but what you've actually been doing is following behind it with a dx over dx. Because what you do is you take the derivative of the variable with respect to whatever the variable is, so x. So for example, when you would have done y equals 3x, the derivative of that would be 3, and then you would follow it with respect to x, whatever the variable is, dx. Well, why are we not following behind with dx over dx? What is dx over dx? It's a 1. So that's why we've never wrote it the entire time, correct? Because you will always do it with respect to x or whatever the variable is, and then you put its variable above it, well, they cancel, right? But if it's any other variable than x, so for now we're going to have a y, we're actually going to get a dy over dx. Does that cancel off? No, so that's going to stay behind. Now note to self, y prime or f prime of x or y over dx, these all mean the same thing. They're just different notations. Leibniz made the dy over dx one, and I don't know who did the other one, and someone decided that there would be 2, and now we have 2. It is what it is, or numerous times. So there's the primes, and then there's the dy over dx. You have to find whatever they want. So they want us to find dy over dx. So we need to isolate dy over dx. That's basically what we need to do. So let's just differentiate this whole thing. So what's the derivative of x squared? 2x. And then technically, I'm going to show this, but only for this step. I would multiply behind with respect to x and its variable, so dx, which just cancels. It's the same thing as me showing you ln e every single time, even though I know it cancels. Correct? Okay. Plus, what's the derivative of y squared? 2y. And then I have to follow behind with respect to x, d, and what's my variable? Y. And then this is where it often goes downhill. The derivative of 25. People write 25. The derivative of 25 is 0. And you don't write derivative of 25 as 25 because you have to think of it as a derivative. You just see a 25 on that side and rewrite. But we're just doing the derivative of each. Yes? Now, all we want to do in the end is get dy over dx by itself. So I technically have 2x plus 2y dy over dx equals 0. And I want to get dy over dx by itself. So what's the first thing I need to move? The 2x. And how do I move it? Subtract it. So I have 2y dy over dx equals negative 2x. Then what do I do? Divide by 2y. And dy over dx equals negative x over y. Done. That's it. Nothing crazy. Just a little more to remember, right? But the derivatives themselves are not at the heart. Okay. B says determine an equation of a tangent. So I need m tangent. What is m tangent? Y prime. And what is y prime? dy over dx. Same thing, right? So if I want m tangent, it equals negative x over y. Now what if they only gave me x equals 3? How would I get y? They gave me 3, 4, but how did they get the 4? 3, 4 is a point on this equation, correct? So they'll just put a 3 in for x and solve for y. You end up getting 2. You get plus or minus 4, but we're only doing 4. Okay. So in the previous we did m tangent, we only had x's, yes? So we plugged in x's. Now we have an x and a y, so we just need to plug in the x and the y. It's nothing crazy. So we are going to get negative x over 4. Negative x over 4. Try again. Negative 3 over 4. Sometimes I scare myself. So that's my tangent. What would the normal be? If the tangent is negative 3 over 4, what would the normal be? 4 over 3. It has to flip from being a negative slope to a positive slope to be perpendicular, right? Normal slopes are perpendicular, and your rise becomes your run, and your run becomes your rise, right? So that's why we get negative becomes a positive, so the slopes are perpendicular. And then the rise becomes a run, so it's 4 over 3. And the run becomes the rise. Okay, and then our equation is just y minus 4, y minus y1 equals negative 3 over 4, x minus 3. Done. Point slope form. So nothing crazy. Do you want to know why implicit is often done wrong? There's 2 reasons. One, you don't change the derivative of 25 to 0. I'm not joking. That's like top error 101. And the second one is if you look at this example. So we have x cubed plus y cubed equals 6xy. Do you know what people do? They go 3x squared plus 3y squared dy over dx equals 6y prime. What they don't spot is, what is this? That's 6x times y, which is 2 variables multiplied, which is what derivative rule? Product rule. So you actually have to go gf prime plus fg prime for that one. And everyone forgets to do product rule there. Leave yourself a little star. Don't forget it. I'm not joking. This is 101 error. Product rule. You guys won't product rule. You will just do the derivative of 6x times the derivative of y and call it a day. You'll be wrong, but you'll do that. You never do product rule. Do you see how it's a little easy to, so it's easy to oopsie there? Okay. So let's go through this one. So the derivative of x cubed is 3x squared. Technically, with respect to x, and it is the variable x, which cancels. You don't need to show this step. Remember, I'm showing it to prove a point, and I don't know why my purple just went away, but awesome. So that became a 1. Okay. Then I have plus the derivative of y cubed is 3y squared times, with respect to x, the variable is y, so dy over dx equals, and then I have to do product rule of 6x and y. Yes? 6x is my f, y is my g. What's the derivative of 6x? 6. Technically dx over dx, but do I need to write that? No. And then what's the derivative of g? What's the derivative of a y? 1. What's the derivative of a y? dy over dx. People will forget to do that. Whenever you take the derivative of a y, you have to follow behind with dy over dx. If you whisper your answers and I don't hear them, it should not be whispered. dy over dx, I got this. Okay, so we're going to get g, which is y, f prime, which is 6, plus f, which is 6x, and g prime, which is dy over dx. So guys, I have 3x squared plus 3y squared dy over dx. And I'll put a dot in here so I realize that that dy over dx is being multiplied. Equals 6y plus 6x dy over dx. Now, do you remember in 30-1 we did the long convoluted 2 numerical bases to 2 different exponents, and you couldn't actually, you had to solve it algebraically. The only way you did that was log base 10 both sides. You log base 10 both sides, and you distributed, and you got everything with x's to one side and everything without x's to the other, so you could GCF and x out. Same thing here. When in the previous example we had 1 dy over dx, yes? So we got that by itself on one side, then divided what was beside it over. This time I have 2 dy over dx's, do we not? So what are we going to have to do? Get everything with a dy dx to the one side so I can GCF it out. And anything without a dy dx to the other side. Okay, people will get stuck here. These two terms, this one here and that one there, both have dy dx, so they need to join to one side, and the other terms need to go to the others. So I'm going to subtract the 6x dy dx over. So I'm going to get 3y squared dy dx, subtract 6x dy dx, because it's an adding currently. And then I have my 6y on the right side, and I need to take this 3x squared and move it over by subtracting it. So I move the two terms that don't have dy dx's to the right, and I move the terms with dy dx to the left. We agree? Yeah? Okay, now I can take a dy dx out. So I get dy dx, and then what's left over? 3y squared minus 6x. And then this is 6y minus 3x squared. How do I get the dy dx by itself? Divide what's beside it. Remember you did that with all those logs in 30? Same thing. So my dy dx equals, can I take anything out of every single term? What could I take out? A 3, technically. And it has to come out of every term in order for it to disappear. If you're like, I don't know how to do that, then GCF of 3 out of the top, GCF of 3 out of the bottom would cancel the 3's off. It's the same thing, right? So we could just take a 3 out of the top and be left with 2y minus x squared. Take a 3 out of the bottom, be left with y squared minus 2x. Cancel these, and dy over dx equals 2y minus x squared over y squared minus 2x. Determine the tangent at 3, 3. Try it out. So B shouldn't be the hard one. You're literally just plugging in the 3 and the 3 to get your M tangent. So M tangent is going to equal 2 times 3 minus 3 squared over 3 squared minus 2 times 3. So you get 6 minus 9 over 9 minus 6, which is negative 3 over 3, which is negative 1. And then I get y minus 3 equals negative 1, x minus 3, done. Yeah? Okay, we're going to flip over. So you guys are going to try A and B. A, 2x cubed. Is that a product rule? No. X, so I can just go right ahead and do a derivative, right? X squared y. Product rule. Xy cubed. Product rule. Take the negative 1 with the x, or leave the negative 1 out, but you'll have to distribute through your product rule. So I always just take the negative with the x. Now this one, e x to the y, product rule, and then xy. So try A and B. The key thing is that if you just take a y, it's just a y. If you take the derivative of a y, you have to follow behind with dy over dx. Okay? So if you're just taking a y and doing nothing with it, you can write it. You take the derivative of y, you take whatever the derivative is, and follow behind with dy over dx. So if I take the 2x cubed, I get 6x squared. Technically dx over dx, but I don't have to write that because it just goes away. Then I go plus g, so this is f, this is g. So I go g, f prime, so the derivative of f prime is 2x. I don't have to follow behind by a derivative because I didn't take a derivative of a y yet. Yes? So that's g f prime plus f g prime. What's the derivative of y? 1. And then because I took a derivative of y, I have to follow behind with dy over dx. So that's just the product rule of that first one. Then you can either take the minus with the x, or you can just go minus and then do product rule of xy cubed, which is what I'm just going to do. I'll leave the minus here and do the product rule of xy cubed. So this is my new f, this is my new g. So I go g, which is y cubed. Did I take the derivative of a y? No, I just wrote y, right? So it's g, which is y cubed, times f. The derivative of f is 1. but it's an x, so I don't have to follow behind with anything. Plus f, which is x, and then the derivative of y cubed is what? 3y squared, and then I took the derivative of y, so what do I have to follow behind with? dy over dx, and then it equals, what's the derivative of 2? 0. So my next step is going to be to distribute this minus sign through. So I'm actually going to get 6x squared, y times 2 times x is 2xy, I can write them together, plus x squared times 1 is just x squared, dy over dx. And then to remind myself that I have to get the dy over dx's together, I just put a little dot in there to remind myself that those are the terms that are going to have to go together. You don't need that multiplication dot at all, right? They are multiplied without it. And then I have minus y cubed. And then I have to distribute the minus through, so I get minus 3xy squared times dy over dx. Equals 0. After this, it should be easier because anything without a dy over dx moves to the one side, and every term with a dy over dx stays on the other side. So I am going to subtract the 6x squared over, because it doesn't have a dy over dx. Gone. Then I'm going to subtract the 2xy over. Subtract 2xy. And then I'm going to add y cubed. Then I'm left with only two terms on this side, and they both have a dy over dx. So I'm going to rewrite this step. Later on you won't have to, but I'm going to show it so I don't lose you. X squared dy over dx minus 3x squared y squared dy over dx equals y cubed minus 6x squared minus 2xy. You could have left them in the same order. I just wanted to put a positive one first. But had you left them in the same order, it wouldn't matter. Now what's my next step? Why did I get the dy dx's on one side? So I can GCF a dy dx out of both of those terms. So then I'm left with dy over dx. When I take dy over dx out of x squared, I'm left with x squared. Take dy over dx out of this 3x squared y squared dy over dx, and I'm left with just 3x squared y squared. And it equals y cubed minus 6x squared minus 2xy. Then how do I get dy over dx by itself? Divide by what's beside it. X squared minus 3x squared y squared. Can I take any GCFs out of them that'll cancel off? No. So I'm going to rewrite it because I can't just leave it as dy with some scratches in this over here. So I write dy over dx equals, and there's no common terms that can cancel. Now, sometimes you have to match their stupid answers. So sometimes in the textbook, they'll pull an x squared out of the bottom and they'll write it as x squared 1 minus y squared, even though it cancels nothing off, but they do that because they feel like it. And then they might take like a 3x out of these two terms and write it, like they do some weird things. Then you just have to match what they have, but this is where I keep the what's going on?
I think you added extra squared to the x on the...
Which one? The bottom one? Top one? This, oh gosh, where?
X, y squared.
Oh, like here, way back when?
Yeah.
No one corrected me? There. It was never there. Can't go back and roll back the tape. The 2 never appeared. It was totally there. Okay, cool. So, this one, I'm just going to help you guys set it up, and then I'm going to make you get to the end of it. X and e to the y are being multiplied. We agree. I'm going to have to do what rule? Product rule. Hey, it's 2p's. I always say them wrong anyways. All the time.
I meant.
You knew what you were saying. You meant product. Okay. So we do G, which is what? E to the Y. We agree? Did I take the derivative of it at all? No. So do I follow behind with the dy dx if I did not take the derivative of it and just rewrote it? No. So that's my G. Then I multiply it by f prime. What's the derivative of x? 1. Plus f, which is x. What's the derivative of e to the anything? You rewrite it, e to the y, ln the base if you so choose to write it, but what is ln of e? And then the derivative of the exponent. What is the derivative of a y? Yeah, it would just be 1, because y, the derivative of y is a 1, but I don't have to write that. And then I took the derivative of y, so I have a dy over dx. So it technically 1 dy dx. Do I need the 1? No. Equals, what's the derivative of x? 1. Minus, what's the derivative of minus y? Yeah, minus 1 dy over dx, and I'm just not going to write the 1. So you need, there's two terms. There's this term here, and there's this term here that have dy dx's. Yes? They need to move to one side, and then the other terms to the other. Try it out. So we have, I'm going to move the e to the y over with the 1. So I'm going to be left with x e to the y dy over dx. And then I'm going to add this dy over dx over, so I'm going to get plus dy over dx. If you so choose, so that it makes it a little more easier for you, this is being multiplied by dy dx, correct? What is being multiplied here so people don't drop it off? It is a 1. So if it makes it easier, put a 1 in front of there so that when you GCF it out, you don't just drop it off. And then it equals 1. This 1 stays. And then I'm going to subtract the e to the y over. So now I have my two terms that have the black lines underneath at one side, and then the e to the y, and a 1 on that side. Now I can take a dy over dx out, and I'm left with x e to the y plus 1, which a lot of people will tell me it's just x e to the y and drop the 1 off. Remember, when you GCF out of two terms, you better still be left with two terms in your brackets. That's the key thing, because if I distribute it back, I should get back what I had. So I get 1 minus e to the y, and then I'm going to divide by x e to the y plus 1. And then dy over dx equals 1 minus e to the y over x e to the y plus 1. Yeah? We have one last one that we're going to go through today, and then we're doing a higher order one tomorrow, which means just a degree, like second degree. So like second derivative, second degree. I don't know what I'm saying. Y primes to y double primes. Okay? So this one we're going to do, it still is just differentiate, but it has trig. So this one is a basic derive, like we did today. This one we have to remember is y squared and an x being multiplied, so I have to use what rule? Product rule. Yeah? Okay. So what's the derivative of sine x plus y? What's the derivative of sine? Cos x plus y. And then what do we have to follow behind it with? 1 plus dy over dx. Okay, then this side we have an f and a g. So we're going to do g, which is cos x, f prime. What's the derivative of y squared? 2y dy dx. plus, so it's gf prime plus f, which is y squared, g prime. What's the derivative of cos? Negative sine x. Now, here is where everything goes downhill. People are like, I don't know how to get the dy dx's together when I have a cos xy, x plus y being multiplied by this. Whenever you have a chain rule, paying attention, a chain rule with a dy dx, you actually have to do the chain rule and then distribute through it. Because the only way we can get dy dx's together is if we have a term, a term, a term, a term, a term. Currently, we have something being multiplied by two terms. Yes? So whenever we have a chain rule, you're going to have to take this cos x plus y and distribute it through so that we don't have two things multiplied. We're actually going to distribute it through and we'll have terms and terms and terms and terms and terms. We have to have multiplications. So remember that when you are doing implicit, that if you have a chain rule, you need to distribute through before you can get the dy's together. So here we're going to get cos x plus y times 1, which is cos x plus y. And then we're going to get two terms out of it. Cos x plus y times dy dx is plus cos x plus y dy dx. So there comes two terms from this chain rule. Do you see that? You had cos x plus y times this. You need to distribute it through so that I get a term, another term, and another term. Because our goal is, once we have all just terms, not multiplication stuff, is to get everything with dy dx to one side and everything without it to the other. So we had to distribute the cos x plus y into our chain rule to get the two terms. And then now we have 2y cos x times dy dx. And then it's minus y squared sine x. Now everything with a dy dx, which is this term and this term, needs to come to one side, and then the other two terms without dy dx need to go to the other. Did you just touch his head and say, oh, I understand? Did you just suck the understanding from Eric's head? So, that was, yes, now you both understand. It was like an Eric... yeah, knowledge share. You just touched a knowledge share across. Okay, good. I'm good with it. So we have cos x plus y dy dx minus 2y cos x dy dx equals negative y squared sine x minus cos x plus y. Take your dy dx out of this term and this term now. And we're left with cos x plus y minus 2y cos x equals that. And then divide it over. So I'm going to get dy over dx equals negative y squared sine x minus cos x plus y over cos x plus y minus 2y cos x. Now, I'm going to share with you what the homework is going to be. So this is part of it. So, write this down. This will be the first part of the homework. It's page 215, 5 to 15 odd. Page 215, 5 to 15 odd. If you don't work on it tonight, it's going to be due after tomorrow, because I'm adding 4 more questions on tomorrow. So it's depending on whether you want to start doing some of it tonight while it's still fresh in your head.